guys, it's Miss Seipel, and today we're going to talk about solving simple equations. And to get ourselves started, we're going to go over some vocabulary. So an equation is a statement that two expressions are equal. 2 times 4 plus 2 is an expression by itself. 14 plus 2 minus 6 is an expression by itself. Both of these are equal to 10, and if I write them with the equal sign between them, I'm making a statement that these two expressions are equal. This is called an equation. A linear equation in one variable has to be written in the form ax plus b equals 0, where a and b are both constants and a cannot be equal to 0. So if I start with an equation like 3x equals 6, this is actually a linear equation in one variable because I can subtract the 6 from each side. Remember, I have to do it to both sides here. And I will end up with 3x minus 6 equals 0, which can be changed to 3x plus negative 6 equals 0. So in this case, the a is 3, the b is negative 6, and it is in this form, ax plus b equals 0, and a is not equal to 0. A solution is a value that makes an equation true. So we have an equation down here, 2x equals 8. And in order for this to be true, x would be 4. 2 times 4 would be 8. So 4 is your solution. Inverse operations are two operations that undo each other. So addition and subtraction are an example of inverse operations, as are multiplication and division. Equivalent equations are equations that have the same solution. So here we have another equation down here, 13 equals 3x plus 1. In order for this equation to be true, x must also be 4. 3 times 4 is 12, plus 1 is 13. Since both of these equations down here have a solution of 4, they are equivalent equations. The addition property of equality states that if you add each side of an equation by the same non-zero number, you'll have an equivalent equation. So if I'm given an equation like x minus 3 equals negative 5, in order to solve this, I want to isolate my variable. I want to get x by itself. So I'll add 3 to both sides. What this does, my minus 3 and plus 3 here cancel out. They're worth a total value of 0. So I'm left with x, and negative 5 plus 3 equals negative 2. So after simplifying, I have an answer of x equals negative 2. The subtraction property of equality says if you subtract each side of an equation by the same non-zero number, you'll have an equivalent equation also. So in this case, the equation that's given is 9/10 equals y plus 2.8. So if I subtract the 2 and 8/10 from each side here, I'm left with negative 1 and 9/10. And over here, I'm just left with my variable, y. So in this case, after simplifying, y is equal to negative 1 and 9/10. The multiplication property of equality says if you multiply each side of an equation by the same non-zero number, you'll have an equivalent equation, as long as you do it to both sides. So if my given equation here is negative n divided by 5 equals negative 3, I can solve that by multiplying each side by negative 5. When the negative is right here in the middle, it can go with either the numerator or the denominator. Just to solve the problem quicker and get rid of the negative and the 5 at the same time, I put that negative with my denominator. So I'm going to multiply each side by negative 5. It's the opposite of dividing by negative 5. So when I do that, in this side, I simplify, I have n, and on this side, I end up with 15. So n equals 15. The division property of equality says if you divide each side of an equation by the same non-zero number, you'll have an equivalent equation. So in this case, the given equation is 1 and 3/10 t equals 5 and 2/10. So if I divide both sides by 1 and 3/10, here multiplying by 1 and 3/10 and dividing by 1 and 3/10 leaves you with 1t or t. And over here, 5 and 2/10 divided by 1 and 3/10 is 4. So for my final simplified answer, t equals 4. So let's use this to solve a real-life equation. So on January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees at 9 a.m. to negative 4 degrees at 9:27 a.m. How many degrees did the temperature fall? Well, the first thing we want to do is make sure we understand the problem. So in this problem, they're asking us to figure out how much the temperature changed between 9 a.m. and 9:27 a.m. So I need to make a plan. So I know that the temperature started at 54 degrees. It fell, so some amount of degrees, and it ended, or it landed at -4 degrees. So D is going to stand for the amount of degrees that the temperature dropped here. Once I have an equation, I can actually solve an equation like this. Okay? So I'm going to subtract 54 from each side. This will cancel out, and I'm left with negative D here. And on this side, -4 minus 54, I'm at -58. So right here, I can actually add in a 1, -1D, and I can divide each side by -1 here. And the amount of degrees that this guy dropped was 58 degrees Fahrenheit. After solving, the last thing I want to do is always look back at my problem and make sure that my answer makes sense. In this problem, if I start at 54 and I'm subtracting more than what I started with, I know I'm going to end up with a negative answer, so seems reasonable. All right, one more. The length of an American flag is 9.5 feet, or 1.9 times its width. What is the width of the flag? So they're asking us to find the width. And we know that 1.9 times our width will equal the length of 9.5. So once I've set up my equation here, I can solve this guy where I'm multiplying by 1 9/10 by dividing each side by 1 9/10. So when I have 1.9 and I divide by 1.9, I'm left with 1. So 1W. And over here, 9.5 divided by 1.9, I'm left with 5, I believe. So in this case, 1W is just worth W, so the length here is 5